So hello everyone and welcome to our comprehensive presentation on password cracking and the cryptographic solution for this. So we are a team of four, myself, Roshan. I have my teammates with me, Alistair Davis, Kirti Vasu. We will be talking to you about password cracking, cryptographic solution, why it's really important for us to do it. Moving on to the next slide. So what does password do for us? It gives us the authentication and gives us the protection for all our important secretive documents that we have, right? What if the passwords are weak? People will be easily able to crack these passwords and they'll get access to these sites. And that is where we come into play and we make sure that we do not give easy access to people. Talking about brute force attacks, brute force attacks is the most common way to attack lobby. Brute force attacks is trying all the possible ways of um, trying to get the password. And the implications of a weak password security, risk of account breaches, potential for financial losses due to unauthorized accesses, damage to personal and professional reputation. Cryptographic solution. So the solution that we are getting, this is the overview for that. So first, we like to do password hashing for it. For hashing, what we're trying to do is use hash functions to completely change message that we're trying to do. And key stretching is techniques like PBKDF2 and bcrypt and bcrypt add computational complexity to password hashing by making it difficult for brute force attacks. And memory hard functions use script and argon2 algorithm to increase the memory of compute, therefore making it even more difficult to use brute force password hashing. From here, my teammate Alistair will be explaining about.
Yeah. So coming to the solution one, PPKDF2. So it is password-based key derivation function. So it is a cryptographic algorithm used to securely derive cryptographic keys from user-supplied passwords. So it applies the hash functions repeatedly, so making brute force attack computationally intensive and effectively protecting your user account. So moving on to the next solution. So the next solution is bcrypt. So it has secure storage and it is slow and adaptive, and it has salt, so which generates a unique salt for each password, further enhancing security against pre-computed attacks. So moving on to the solution three, so which is a script. So it is designed for password security. So it is a memory hard password based key derivation function that was designed specifically to be resistant against brute force and GPU based attacks. And it has memory hardware computation, and it has wide adaptation. So it is widely used in various applications including password storage and cryptography wallets, etc. So moving on to the fourth solution, so it is Argon 2. So it is a memory hard function making it resist to GPU based attacks, and it allows for customizable parameters to adapt to change in hardware and security requirements, and it is designed to be resist to side channel attacks and provide strong password hashing. So, and moving on to yeah, moving on to the best practices. So use strong unique password and regularly update passwords and enable two two-factor authentication and always use a password manager. So the code part will be explained by Pranava.
So yeah, now moving on to the implementation of password hashing method. Firstly, we get a password as an input from the user, and then we we use that password in a to generate a hash for that password. So we're gonna use hashlib library to generate a random hash value for 16 bytes to that password. So here's our demo. Uh, So we enter a password. It uses the library, and it converts the input password into 16-bit hash value. So yeah, this is our hash 16-bit hash value. So the next method is bcrypt implementation. So it is quite similar to password hashing. Here we are getting the password as an input, and then with the hash password function, with the help of the bcrypt library, we are generating a hash value for that input password. So this is our password, and this is our hash value. Next, memory hash will be explained by Kirti.
Yeah. Moving on to the next topic on the solution is the memory hot functions based attacks, attacks that are help to solve the brute force attacks, which is a script and organ 2. First, let us see the script algorithm and the solving Python program. First, we are importing the bin ASCII, which is responsible for by converting binary to ASCII values. And then we are importing the algorithm called a script, and we are importing the OS for the operating system based operations. First, we will get the input from the user. First, we will get the user. Let us take password name as K2000. And then you can see that before you will check the before two solutions explained by Pranava, like they are quite smaller to the hash values. Like this is it is approximately around 128 byte values, and then if you see the output of this script value, it almost are around 256 bytes value stored. As you can see that script is more stronger than the previous two solutions. Moving on to the next solution, which is Argon 2 solution. Here we are basically importing the bin ASCII and OS for the prerequisites for this program, and we are importing the Argon 2 as the main algorithmic approach which is used for this program. We are first we are inputting the uh, we are inputting the password, and we can see that uh, the password is called to the with the two parameters called hash password and then the salt. We are passing the value of this password to the generate organ to hash value, which is predefined by set of initialized values, salt, time cost, and then the memory cost for the execution and parallelism and hash length. Yeah, afterwards, if the salt is not initialized or none in the case, we are uh, we are we are randomly initializing the value which is built on OS system of 16 bytes, and then we are Argon 2 hasher is the inbuilt library in the Argon 2 library, which is used to call the set of values with the predefined values that are in the user defined functions. Then we are returning the hash password and then the salt to the main function, and we are printing the hashed password and then the salt value which is present in the argon 2 solution. Then you can see that argon 2 has something around 256 bytes, and then the salt value is around 16 bytes of values. Then that's all about the our project, explaining 4 solution with their code. Thank you for the explaining the project.